We've done a lot of different types of functions throughout the year, so now we're going to kind of recap all the different functions and find their domains and ranges. So the first one on here is a quadratic. So since we have an x squared term, we know that this is a quadratic. And a quadratic, the domain of a quadratic is always all real numbers. The range is going to be based off of that vertex point. So if we were to graph this, we know that it's opening down. So it looks like that. To find the vertex, we have to do x equals negative b over 2a. Find the x value, plug it back in to find the y value. So if we do negative b over 2a, we get x equals negative 2 over 2 times negative 1, which is negative 2. So x is 1. So we know that the vertex point here is going to be 1 something. We have to plug 1 into our function. So we're going to have negative 1 squared plus 2 times 1 plus 1. And when we solve that, we get 2 for y. Since our parabola is opening down, the graph is going to be below. So the range is going to be y is less than or equal to the y value of the vertex, which is 2. Now if we go to the right of it, that is a rational function. So the domain for a rational function is all real numbers except for the restrictions. So x cannot equal 4, because that's our restriction. The range will be all real numbers except for our horizontal asymptote. So we check the degrees, they're both the same. So we divide the coefficients in front. So 1 over 1 is 1. So we have a horizontal asymptote. I'll write this over here. Horizontal asymptote of y equals 1. So our range is going to be all real numbers except y cannot equal 1. And the next one underneath, you just have an x to the first power and you have a y. So this is a linear. And a linear is nice and easy because it's all real numbers for both. And now in the next one, this is a radical function. Radical. And it's a square root function. So we know that when we have a square root, you can't have a negative underneath the radical. So to find the domain, you're going to take what's underneath the radical, the x plus 2, and you're going to make it greater than or equal to 0, and you're going to solve it for x. So if I subtract 2, x is greater than or equal to negative 2. So that's your domain, greater than or equal to negative 2. To find the range, plug negative 2 back in. So negative 2 plus 2 is going to be 0. Square root of 0 is 0. 0 times negative 2 is 0. Since we have a negative 2 in front, the graph of this one is going to be down. So since it's going downward, the range is going to be less than or equal to 0. Okay, now the next one is also a rational. So I'm going to do rational in blue so it looks the same. Here's a rational. So you have to factor this in order to see what our restrictions are going to be. So we could factor this. We could take out the top. We could take out an x. And we have x squared minus x minus 6. And on the bottom, we can take out a negative 3. So we have x squared plus x minus 6. And then we can factor, again, running out of space. So multiplies to negative 6 and adds to negative 1. So we can, on the top, have x minus 3 and x plus 2. And on the bottom, we can have the opposite, so x minus 2, x plus 3. So I'm just going to change this. So we still have the x. Let's redo this. X on the outside. And then this was x minus 3, x plus 2. On the bottom, we had a negative 3 on the outside, and it was x minus 2, x plus 3. So nothing's going to cancel here since they're opposites. So your domain is going to be all real numbers except your restrictions. So x cannot equal 2 or negative 3. And then the range, the top degree is bigger than the bottom degree, so there's no horizontal asymptote. So there is no restriction on the range. So the range is just going to be all real numbers. Okay, the next one is a quadratic because you have an x squared. So we'll do that now. So the quadratic. So we're going to find the vertex. So we know that the domain is all real numbers. But for the range, we have to find the vertex. So we're going to do negative b over 2a, and we're going to find the vertex. This opens up. Okay, if you do negative b over 2a, you'll get the x value is 4. When you plug that back in, you get 1 for y. So since this graph is opening up, the range is going to be y is greater than or equal to 1, which is the y value. And then the last function here is a cubic function. Cube root function, because it's the little 3 is our index. So when you have a cube root function, again, nice and simple. All real numbers for the domain, all real numbers for the range. Okay, so use the information that I put on Canvas to figure out the domain and range of these different functions. So I kind of wrote it out as like a step-by-step thing of how you find them. So if you're getting confused, I would look back at that and check it out.